Okay, Bismillahirrahmanirrahim. Now we discuss about the Turing machine. So we talked about Turing machine, but before that we had what? इसका वो पेन कहाँ गया? Yeah. Okay. Before we discuss Turing machine, we said we had the regular language generated by regular grammar, and then this was accepted by the finite automata or finite machine, right? Like we have a raised power n, it could be done. If the language we have is a raised power n, okay, this is a regular language, it can be accepted by a finite automata. So what is a finite automata? A language, okay, L, constructed by the sigma, by the alphabet sigma, which is accepted by some finite automata, is called the regular language. Somebody say, what is a regular language? A regular language is what? It's a language, okay, constructed, a language constructed by alphabet sigma, which is accepted by finite automata, is called a regular language, right? Similarly, we said then we have the context-free language. It is being generated by context-free grammar, and it is the push-down automata which accepts this. So if somebody tells you what is push-down automata, or what is the context-free language, it's a language constructed by alphabet sigma which is accepted by PDA, push-down, right? Similarly, we have the context-sensitive language, which is done by accepted by what? Generated by sensitive grammar, and is the linear bounded array, okay, or linear bounded automata, okay, or the bounded Turing machine, we could say like that. But the superset of it is if we have which language? What is the type 0 language? What is the grammar called? Unrestricted.
Yes, sir.
Okay, you forgot that?
No, sir.
What is the language? Recursive and enumerable language. Recursive and enumerable language. Accepted by which? Turing machine. So we have here the Turing machine now. Basically, if we have the regular language, it will be accepted by Turing machine, because Turing machine is the boss. It is a superset of all. If we have the PDA, if we have the context-free language, accepted. Context-sensitive language, accepted. Recursive and enumerable language, accepted. The diagram I have given, hierarchy, no Neom Chomsky hierarchy. It's the same thing, na? I have given you that. तो आप ऐसे देख रहे हो जैसे पढ़ा ही नहीं होता फिर, ठीक है? Okay. So the Turing machine is, which is the superset of all, right? So Turing machine accept everything. It is a regular language or context sensitive or context free or recursive or enumerable language. It will be accepted by the Turing machine, right? So in my finite automata, we have literally no memory. So that's why we was taking only single input. But in case of my PDA, I had a stack. I had what? It was a finite automata plus stack. In my Turing machine, and in my stack, I was only able to see the top of the stack, that is it. Right? I could read only the top of the stack. But in case of my Turing machine, we have an infinite tape. We have what? Infinite tape memory. It's called tape memory. We have infinite tape memory. Okay? Which has some alphabets from the sigma, maybe A, B, C, whatever. Okay? But it's infinite. Okay? That means it has no limit. But when we finish with our A, B's and C's, whatever the inputs we have from the sigma, it will have the blanks. It will have what? We put the blank in it. So if we want to formally define the Turing machine, we'll also have a blank in it. We will have the sigma in it. Okay? Getting? We have all those things what we have seen, but we also have the B, the blank. The most important thing in the tape is we can read this way or we can go this way also. We can read right, we can read left. So therefore, if a language is like, see, if I give to the FA raised power n, it can be, it's a regular language. But if I have a raised power n, b raised power n, means jitne a utne b, this won't be accepted by the FA because FA can't, is not that powerful. Therefore, we need for that the PDA. But if I have a raised power n, b raised power n, c raised power, for example, m, and I say m is greater than or equal to 0, etc., this won't be accepted by the PDA. We need more powerful machine. This will be accepted by the Turing machine. If the language is like this, right? But Turing machine can accept regular language, also this, because this is more powerful. We are moving forward, no? You getting me? If you are in a BCA third year, fifth semester, you are already done one, you are already done second, you are already read this, or already read this. But you are BCA first semester, you can't read the TOC, right? But if you are BCA fifth, you can answer the other questions also. Why? Because you have done that. So Turing machine is a sum total of all these things. So Alan Turing actually gave this machine, it is the abstract machine. It is the dialogue with this is that if there is any problem, if there is which is solved, it can be solved mechanically. Means which you can have an algorithm, stepwise, na? That's called, if we have, write down. Any problem which can be solved mechanically, i.e. that is, if we have algorithm for that problem, then that problem can be solved, by Turing machine. So Turing machine is typically the abstract computer. This is an abstract machine which is like a computer. It was before we have a computer, we had this abstract machine, and because of this, we started creating the computers in the real sense. Getting the point? So a problem which can be solved mechanically, that is, if we have an algorithm for that problem, then that problem can be solved by Turing machine. Okay? So, if there is no algorithm, that means that problem is non-solvable. You can't, if some problem cannot be accepted by Turing machine, that problem is what? Unsolvable. You can't solve it. You getting my point? So, is it computable or non-computable? So, that problem is uncomputable. You can't compute that. You getting the point? Okay. So, that's why I say very powerful abstract machine that could simulate any modern day computer. हालांकि slow है. So, that is what the problem is, undecidable or solved. Huh? अगर कोई प्रॉब्लम है ना इसको ट्यूरिंग मशीन सॉल्व नहीं कर सकती है, so that problem cannot be solved. That is undecidable. That is what? So that's why we say computability versus decidability. Right? Write down this is your assignment. Computability versus decidability. What is the difference between computability and decidability? Answer is this thing actually, which I have told you exactly. Now, in a Turing machine, what we have? We have an infinite. We have infinite what? We have infinite memory. We have infinite tape memory. Okay? And we have a kind of a computer called finite control. It will tell us something to be written on the tape or something to be read from the tape. What you want to read from tape, what you want to write to tape. Right? So that is your finite control decides that. मुझे टेप से रीड क्या करना है, राइट क्या करना है, लेफ्ट चलना है कि राइट चलना है. So the finite control will decide what? It will decide few things. Right? Finite control will do what? Should we move right or left? Finite control will tell us. Move right or left. Right or read. Read is also called scan. Write is also called something called update. Yeah, upgrade. You want to write on a tape? What you want to write on tape? So these are, if you could see B's and then there's the X's. These are two different. These B's are the input. This is from the sigma. Okay? And these X's are from the tau, the capital gamma. This tau is a set of symbols to be written on the tape. Okay? These tau is the set of symbols which we want to write on the tape. With the example, you understand it properly. And these B's or A's or whatever is the sigma. If the sigma is 0, 1, so that means I can have input as 0 or 1 only. My language will have only zeros and maybe my tau, the gamma, is having X, Y. So that means I can write or read, onto the tape this X and Y only. Getting? So my Turing machine will have 7 tuples. First, Q, set of states, input alphabet, whatever it is. Tau, set of tape symbols which you can put on the tape, you can write on the tape. You replace the input with that X or Y. Whatever this transition function, here we have different transition function, we'll see that. Q0 is the initial state, B is the blanks, because all other which is empty is filled with the blank, and F is the final set of states. Simple as it is. Same, it's very simple, right? Okay. So this is the tape symbols, these are X's, huh? These are the inputs. Okay? And we know that. And B is a? Getting clear. So what is tape? Tape is the? And that will be inside memory. And we can read or write only where the tape head is. That is important. We can read and write where the tape head. So tape head is very important. Where you want to read. Where the tape head is, you can read only that thing. And you can write or update that thing only. Getting? So finite control is like a CPU, which decides all this. कि कौन पढ़ना है, right जाना है, left जाना है, क्या करोगे? So it will be done by the finite control. Right? And the transition function here is about what? Transition function is that you have on some state, maybe you are on some state, you are, इसने लिखा, okay. Delta QX means you are on some state Q and the input variable is X. You are getting from the tape X. Whatever that is, that could be, whatever you are getting from this is the, what is on the tape, under the tape head. It could be from the sigma or could be from the tau, right? It could be either the input from the sigma, that is ABs, whatever, or 0, 1s, or the tau. Tau is the tape symbol which you want to put in place of that input. You want to write onto that. It could be that thing only. So you are getting on a state something and you are sensing there is X or there is some input variable, whatever. And you accordingly go to the next state. You go to the P. And you replace this X with the Y. And then you decide whether you go to right or you go to left. You have to do what? You are on a state, you take some input. For example, I am on this state. I am on state Q. And I am reading 0. Or I could have read the X, which is the tape symbol. The tau, which is the gamma. Because I told you I have the sigma and I also have the tau. Sigma is the inputs like zeros and ones. The input alphabet. The tau is like X and Y's or whatever, which I want to replace these zeros and Y's with these. Why we do that, I will tell you the example. Okay? Now, you are reading this thing. Accordingly, what will happen? You go to the next state. You go to the next state. Or in the tape, you are reading this 0. Should you go to the left or should you go to the right? It is this thing. And you are replacing this 0 with this symbol, for example, Y. With the tau symbol, which is in the gamma, the tape symbols. Okay? You are reading that 0 input and you have to replace that. Sometimes you do not replace, sometimes you replace. It's up to the choice what we have. And accordingly then we have to decide, should we go right or should we go? So our transition function will be, you are on some state Q, you are reading something from the tape, you are going to the next state, okay, and you are replacing this X with some Y, and you decide should you go? Simple, right? Can you tell me what is the transfer function again? This Q is some state. You are not necessarily state or on any state. X is where the head is. You are reading it from the tape. And you are replacing this X with, but before that you go to some other state, which is, and D is the, bingo. So Q is the, X is the, pointed by the tape head. This X could be the input, this X could be from the top. That is the tape symbol. And then you from Q to P, you change the state. After the move, X is replaced with, then if the D is left, then the tape goes to the left. If the D is right, it goes to the, does it make sense? Very simple. It's very simple. Right now, it's very simple. So, let us skip this for a while. We go to the, because I have a meeting. I will give you some example, one example. We have 0 raised power n, 1 raised power n. We have 0 raised power n and 1 raised power n. We want to check if our string has as much 0 as much 1s. Like we did, this is, again we did use the PDA, push down automata. The regular language, is this a regular language? No. Because regular language में क्या होता है, एक ही input होता है, यहाँ दो check करने हैं, तो वो उसमें possible नहीं था, PDA में stack से हमने किया था वो, ठीक है? अब we want to check using the TM, the Turing machine, right? So we have input tape. We have what? We are starting from here, for example. Okay? And we replace this 0 with the X. Okay? So what we do is actually is, we replace this 0 with the X, and we go to the next one. We replace that 1 with the Y, we come back to the next 0, replace it with the X, go to the next one, replace it with the Y, okay? Go to the next 0, replace it with the X. And now you move on here, go to the next Y, go to the, replace it with, now after that you have no more X's left, no more Y's left. You are reading what? Blank. So you accept it. I will tell you again this example. But let us see the state diagram first. I will tell you how it happens. Let us do it first. Let us have a complete diagram. We understand it. Okay, we are here. Going back one step. Here, this is our state diagram. Let's understand it. And let us understand it using our input. Say we have input 00011. This should be accepted. This should be, why? Because 3 0 3. This is 0 raised power 3, 1 raised power 3. So our language was saying 0 raised power n and 1 raised power n. And here n is equal to 3. Here n is equal to, so this should be accepted. Our starting state is what? Q0. This is my input tape. Okay? So let us make it here. This is my input tape where we have 0 0 0. Then I have 1 1 1. And after that I have what? I have blanks. Right? Can I change the color of the pen? Yes. Now I am at Q0 initial state. I am at Q0. I am reading 0. I am reading what? Or it could be X. It could be, you read 0 or you read X. X is the tape symbol. X is what? And 0 is the input symbol. So 0 belongs to the sigma and X belongs to the tau. Right? Here tau is X comma Y and sigma is 0 comma 1. This is my thing. This is my Q naught. This is the Q. All the states is Q. B is for blanks. B is for what? We have 7 tuples. B is for blanks. And transition function say you are on some state, you read some input. Accordingly, you have to write something on the, that's what I say wrong. This is, you have to write something on the, this X is the, what you have to write. Because our transition function says what? What is my transition function? Transition function is, if you are on some state P and you read some X, okay? You go to some state Q, other state, okay? And you change this X with Y. And you decide you want to go left or you want to go right. That's the decide. You have to decide here. So this is what I do here. I am reading what? My tape head is here, for example. I am reading 0. Gotcha? After reading 0, what should I do? I replace this 0 with the X and I move to the right. So I replace this, here I read the 0. Now, I had to replace it with some variable here. So I am replacing with x and I am going. So that means after I read the 0, I replace the 0 with the, and I move right. My tape head is here now. My tape head is, there is 1, there is different story. But if it is 0, I am on the tape head. Many zeros. Replace it with, so don't change it, but move right. I am reading 0, replace it with, so no change, but move, tape head goes here. This will come in a loop until all the zeros are finished. So that means read 0, replace it with, and move. I am here now. My tape head is under the 1, right? Can I read the 0 now? No, there is no 0. Is there any y there? No, there was no y's anywhere, right? So I have now what? So on Q1 I got a 1. What should I replace it with? So I will replace it with y and move to the, so my tape head is here now. I am moving left. Now I am on this state. I am moving continuously left if I found the y, but there is no y under the tape. It is 0. And if I find 0 in a loop, ठीक है? 0 को 0 ही बनाएगा लेकिन लेफ्ट जाएगा. 0 को 0 ही बना लेफ्ट जाओ. 0 को 0 ही बना लेफ्ट जाओ. ठीक है? लेकिन क्या ये 0 है अब? तो ये लूप खत्म हो गई. ये कौन है अब? So it will go here now. It will go. So x को x ही रखो मगर जाओ किधर? x को x ही रखो, या x ही रखो मगर जाओ, अब टेप यहां पर है. ठीक है? I am on Q0. What is under my tape? So this will again happen. So it will replace the 0 with, and it will skip all those 0 and start finding the 1. The 1 has come up here, not here. It is a y. Okay? If it is y, change it with the y only. Zeros अगर है 0 रखो, अगर y है तो y ही रखो. Y मिला ना? तो जब तक पहला 1 नहीं मिलता, इसके बाद y के बाद जो पहला 1 है वो नहीं मिलता, तब तक कोई इसमें रहेगा, इस लूप में. अब 1 मिला ना, तो कन्वर्ट इट इनटू एंड मूव टू. अब अगर आपको y मिल रहे हैं या जीरोस मिल रहे हैं, जैसे y मिल रहा है ना यहां पे, या जीरोस मिल रहे हैं, आप चलते जाओ, उसको लेफ्ट चलते जाओ, लेफ्ट, तो जीरो में अब यहां पे x मिल गया ना, तो यहां पे रुकेगा, इस लूप से बाहर आएगा. जो ही x मिलेगा x ही रखो, लेकिन राइट चलो. अब कहां जाएगा ये? यहां पे. अभी यहां रुका था ना, अब ये यहां पे रुक रहा है. ठीक है? अब फिर से 0, इसको रिप्लेस करेंगे किससे? x के साथ. और जब तक y, अब तो इसको 1 नहीं मिलेगा, अब 0 तो नहीं मिलेगा, y मिल रहे ना, तो अगर y मिल रहे हैं तो y रखो और राइट चलते जाओ, और जाएगा इसके पास लास्ट में. जब 1 मिलेगा उसको क्या करें? कन्वर्ट y, कन्वर्ट इनटू y एंड गो टू. और कब तक लेफ्ट जाओगे? जब तक y या 0 मिल रही है, तो सारे y है ना, तो यहां पे रुकेगा x पे. जहां x मिलेगा तो वहीं रुको, राइट जाओ. अब यहां पे क्या 0 मिल रहा है? क्या इसमें x मिल रहा है? 0 तो मिल नहीं रहा है, तो यहां जा नहीं सकता. अब इधर जाएगा, अब तो y मिल रहा है ना. अब जो x, आपके जीरोस खत्म हो गए ना, जब जीरोस खत्म हो गया x मिला था लास्ट में, तो जब यहां से वापस आया था, ये अब 0 से वापस नहीं आया था, y से वापस आया था. अब y y y y यहां पे आया था. अब वहां x था, x के बाद ये राइट गया, उधर y है ना बैठा, अब y के ऊपर है. अब y के ऊपर जब है तो y को y ही रखो, राइट चले जाओ. अब जब तक y मिलते हैं तब तक y को छेड़ो मत, y को y ही कन्वर्ट करो, लेकिन राइट y y y y. अब यहां पे है ब्लैंक पे, जब ब्लैंक पे है तो राइट पे जाओ, ठीक है, और एक्सेप्ट करो. और अगर इसमें सिचुएशन ऐसी होती कि फर्ज कीजिए मेरे पास 3 जीरोस थे, 2 ही 1 थे. अगर मेरे पास 3 0 थे, शुड नॉट एक्सेप्ट इट. स्टार्ट फ्रॉम Q0, 0 है, रिप्लेस करो विद x, और तब तक चलते जाओ 0 जब तक 1 नहीं मिलता, जब तक कन्वर्ट इट इनटू y एंड मूव टू द लेफ्ट हियर. ठीक है? और तब तक वापस चलते जाओ जब तक y और 0 नहीं मिलते. तो पहला जब 0 मिलेगा ये वाला, तो वहां पे रुको, फिर x मिलेगा, फिर जब x मिलेगा फिर राइट जाओ, यानी कि हेड यहां पर है, इस 0 को कन्वर्ट करो x में, फिर चलते जाओ इसके पास, ये y कन्वर्ट करेगा. ठीक है? और जब तक चलते जाओ कहां जाएगा? 0 पे जाएगा. ठीक है? तो इसको x बनाएगा. अब इसको वापस 1 चाहिए ना, तो ये इधर फंस गया ना, इसने 0 बाय x को बनाया, ये y से आगे जा सकता है, 0 से आगे जा सकता है, तो ना ही 0 है ना y है, सॉरी क्या है, ये y से राइट जा सकता है ना, और 0 से कहां जा सकता है, राइट, ये 0 से जाएगा y से आगे जाएगा, y से तो आगे जा सकता है, जाएगा ना, ये तो y से आगे आगे जाएगा, लेकिन इसको 1 मिलेगा नहीं, तो यहां पे ये रुक जाएगा, यहां पे ब्लैंक है ना, तो ब्लैंक के लिए मेरे कुछ इंतजाम ही नहीं है Q1 पे, so it is stuck here, so it will be rejected, the language will be rejected. You will do this exercise, you will watch the video again and try to do yourself कि क्या हो रहा है, work with your brain, हाँ, use your brain, work it out कि भाई कैसे हो गया, यहां जीरोस, ये क्या करता है काम, पहले x लगाता है 0 को, फिर पहला 1 ढूंढता है, सिंपल, पहले 0 में x डाला, फिर पहले 1 पे चला जाता है, ये स्किप करता है, ये वाला चीज स्किप करता है, जीरोस को 1 पे चला जाता है, उसको y बनाता है, फिर वापस आता है पहले 0 पे, उसको x बनाता है, फिर वापस आता है इस 1 पे, फिर इसको y, फिर वापस इसको x बनाता है, फिर वापस आता है y बनाता है, फिर वापस आता है, तो वहां पे जब खत्म हो जाता है सारा, तो ब्लैंक आ जाता है, फिर ये सारे y स्किप करता है और ब्लैंक मिलता है, तो क्योंकि यहां पे ब्लैंक का इंतजाम है, वो तब है जब x's एंड y's मैच कर जाएंगे, इधर से x एक किया, उधर से y's मैच हो गया, तब जाके इस स्टेट में आ सकता है, ब्लैंक रीड करके एक्सेप्ट करेगा, अगर मिस मैच हो गया तो वो कहीं पे अटक जाएगा, इधर है इधर, अगर जीरोस कम पड़ गए यहां पड़ जाएगा, अगर 1 ज्यादा पड़ गए इधर फंस जाएगा, पास में आए, सो इट विल बी स्टक, विल बी रिजेक्टेड, गेटिंग, दिस इज हाउ ट्यूरिंग मशीन वर्क, दैट्स ऑल फॉर टुडे, यू कैन क्लोज दिस.